This video is going to go through the combined gas law, and just as the name suggests, this law combines Boyle's law, Charles' law, and Gay-Lussac's laws. And it's used to see how the volume of a fixed mass of gas changes when both temperature and pressure change at the same time, or at least you're solving for one of the unknown variables between pressure, volume, and temperature. So the combined gas law is written as follows. P1 V1 over T1 equals P2 V2 over T2. So if we look at this, it's going to be tricky for me to show this here, but I have P and V combined together on the top of this equation, and that's Boyle's law if you remember. Then we have Charles' law, which is the volume temperature component, so V1 over T1. And then we have finally Gay-Lussac's law, which is the pressure-temperature relationship, so P1 over T1 there. So really, if I look at this law and I subbed anything in as a constant, you would see that really it would just cancel out, and that's how we get all of our individual laws here, or how we join them all together to have our combined gas law. So a couple things to keep in mind as we're going through this, just as we have done with all the other gas laws. Whenever I'm talking about standard temperature and pressure, or this STP value, remember we're looking at the temperature being 273 degrees Kelvin, or 0 degrees Celsius, and the pressure is 1 atmosphere, which is the same as 760 torr, or millimeters of mercury, which is the same as 101.3 kilopascals. Remember, your temperature always has to be in degrees Kelvin here. But your pressure, as long as it's consistent between P1 and P2, it can be any of my 4 units. So let's look at an example and see how this can actually be used here. So example, 2 liters of gas is collected at 25 degrees Celsius and 745.0 millimeters of mercury. What is the volume at STP? So there's that pesky little STP again. You need to remember those standard conditions. So just like we've been doing with all of the other gas laws, the first thing that we need to do is outline all of the variables that we have to figure out what's given to us in the question. So I need to figure out my P1, V1, and T1, as well as my P2, V2, and T2. Okay, so before I deal with any unit issues, let's look at our final values that we have here. So I need STP. So because my initial pressure is measured in millimeters of mercury, my final pressure, my P2, must also be that millimeters of mercury. So that's 760 millimeters of mercury. And my standard temperature here, remember it's in degrees Kelvin, it's 273 degrees Kelvin. So I'm trying to figure out this V2 value here. So looking at my variables, my pressures are good. Both of them have millimeters of mercury. My volume, start with liters, I'm going to end with liters, that's good. My temperature though is still posing an issue because I start off here in degrees Celsius. So remember to convert between degrees Celsius to degrees Kelvin. I'm just adding 273. So this one here would be 298 Kelvin. Okay, now I have all my given information. I'm going to plug and play into my equation and solve for the unknown variable. In this case is V2. Okay, you'll notice that I wrote all of the units in on this one. Again, like always, you won't be losing any marks if you don't have units throughout the question. However, when you're dealing with things that are more than just two variables, I do suggest that you use the units as a way to help you guide through the question to make sure that you're rearranging everything properly. If I rearrange everything properly, then I should only be left with liters because again, I am solving for volume, so everything else should be canceling out. When I'm rearranging this, essentially what I'm doing is I'm multiplying everything on the bottom to move it to the other side, and I'm dividing everything on the top to move it to the other side. So really, I can put over here 273 Kelvin and 760 millimeters of mercury. So that will cancel out both of these, so I'm left with only the volume here. So again, like I said, let's look at my units to make sure that everything is rearranged properly. So I have Kelvin crossing out with Kelvin, millimeters of mercury crossing out with millimeters of mercury. I'm only left with liters, which makes sense again because I am solving for the volume here. When you're plugging this into your calculator, just make sure that you put brackets around your denominator if you're not solving in two steps. Because your calculator doesn't know bed mass. So just keep that in mind as you're going through. So if I do 273 times 745 times 2 divided by 760 times 298, I should get the value 1.796 liters. Looking at my sig figs here, going back to the initial question, I can only report two significant figures, so 1.8 liters is my final volume. This one's a little bit trickier, the combined gas law, in order to logic through, but let's try this one. So remember we said if I'm looking at pressure and volume, if my pressure is going to increase, as I see here, then I would expect a decrease in my volume, which is what I calculate. So that makes sense here. Combined with my temperature and volume calculation here, if I see a decrease in the temperature, then because those guys are directly proportional, I should also see a decrease in the volume, which worked out again here. So my final volume for this question, both my pressure and temperature changes will result in a decrease in volume. So my final volume is 1.8 liters.